evening. Welcome to the BS and Beer Show. BS obviously stands for Building Science, of course. Topic tonight, tools of the trade for building diagnostics. I'm Emily Mottram. Tonight we're having BS and Bubbly in my retro tech koozie. Uh, BS is a BS of Beer is a grassroots independent movement meant to share building science knowledge through our local meetup groups and this our Zoom show. The brew crew and our guests volunteer our time each month to bring you what we hope is a fun and informative discussion. We want to encourage everybody in the audience to find a local BS and Beer group. You can see them on the websites, the ones that we know are available. So if there isn't one in your area, start your own. Visit thebsandbeershow.com for more information on how to do that. You can find the video recording on our website, The BS and Beer Show, and also on our YouTube channel. Speaking of our website, our friends over at IMW Group are putting the finishing touches on the website, and it should be live very soon. Big thank you to IMW Group and Motif for helping us make this show possible each month and to bring it to you with the recordings afterwards. So, Mike, if you want to do announcements.
Yes, thank you, Emily. I am Mike Maines. I am drinking a Lone Pine Brightside IPA from Portland, Maine, one of my favorites. Or announcements. We have first and foremost, Travis's Building Science Symposium series kicks off for the fall sessions in Kansas City, Missouri, back to where it all started on September 9th and 10th. We will post a link in the chat for that. Don't miss that if that is in your neck of the woods or you want to travel to beautiful downtown Kansas City. Another conference, the Fine Home Building Summit, will be held September 18th and 19th in Beverly, Massachusetts on the North Shore. It is billed as a premier two-day thought leadership event dedicated to the evolution of residential design, construction, and business practices. The summit will bring together some of the most experienced and recognized professionals in their fields through insightful presentations, empowering panel discussions, and networking. Attendees will gain the wisdom needed to position themselves at the forefront of an ever-evolving industry. That is a mouthful, straight from their website mostly. Many of the presenters you will recognize as past guests here on our show, and as well as our very own Ben Bogey. We'll post a link to
Yay.
that. And teasing our next show on August 7th, back to our regular scheduling. We will have building code expert Glenn Mathewson on. Glenn is always very full of energy, ideas, and knowledge. We don't have a specific topic nailed down yet, but we definitely look forward to talking with him. Ben, I'll turn it over to you.
All right. Thanks, Mike. This evening, I am drinking a rather boring polar seltzer, cranberry clementine, because I just ate dinner and I don't think I could fit a beer at the moment. So this evening, though, I have the great pleasure of introducing Kohta Ueno. Kohta is a principal at Building Science Corporation, a consulting firm in Massachusetts. His responsibilities there include forensic field investigations, enclosure consulting for new construction and remodels, building science research, and energy and hygrothermal modeling. He has been with BSC since 1998 and completed his master's degree under John Straube at the University of Waterloo in 2007. He is also conveniently sized to fit into attics and crawl spaces, which is markedly useful in this field of work. I am not particularly well sized for attics and crawl spaces, but I still end up inside of them. So at those moments, I would appreciate your stature if I had it. Kohta, something that I've always appreciated from you and is your level of diagnostic tool nerdery. So I'm really thrilled to have you here this evening because it's something that I also greatly enjoy. Is there anything I missed in your introduction?
That is a fantastic introduction. Thank you, Ben, Emily, Mike. Great to be here, and it's so fantastic to see all the folks on the show today. Should I just? Oh, I am just so. Yes, I am having a Aeronaut Robot Crush, very nice Pilsner from a brewery that's within staggering distance, which is a fantastic luxury to have. Should I just go ahead and start the share and okay, fantastic. So by the way, I whittled this down to about 25, 30 minutes. My thought is I'll just take the questions at the end, or do you guys normally want to do this where we, stop and start and take questions as we go? What works better for you?
At the end is fine. They can just post their questions in the chat, and one of the three of us will pull them out, and we'll try to get to all of them.
Awesome deal. Okay, so let's just start off with a little bit of an introduction. So I don't know how many of you guys know me kind of as like a researchy monitoring guy, but a lot of my day job is building forensics as an enclosure consultant, looking at screwed up buildings of all kinds, whether it's freezer warehouse down in Florida where icicles are growing out of the roof, or some rich dude's house in Florida where he can't control the humidity and his art collection is getting wrecked, or an airport control tower that's leaking water and causing major incidents. So, what I'm going to talk about are the tools, the forensic kit that I use on a lot of these types of jobs beyond what I can actually see. This is what works for me, and maybe if there are little tidbits that are useful for you, great. And I am insanely indebted to all of these practitioners who came before me, shared their knowledge, shared the tools that they used, all amazing stuff. So housekeeping, these slides are available. Feel free to screenshot whatever you want, but honestly, can get that later, and we'll take the Q&A at the end. The overall structure that I'm planning on this talk is the topics of air, water, heat, and combining them in various ways, air and water, etc. So just starting off with air as a topic, first of all, most of you probably are well versed with blower doors. There's no need to go through blower door 101. Retrotech, Energy Conservatory, all those guys have an amazing number of resources. This is just a couple of little bits of the tips and tricks. I'm going to skip over this bit. Just so you know, this is an hour-long presentation that I'm trying to compact into half an hour. So one of the things that's often really useful is what is the interior to exterior pressure? I've dealt with a case of a swimming pool where they blew it up like a balloon and rotted out all their walls because basically they were taking the hot, humid air from inside and pushing it out through the walls. So basically this type of measurement, just stick a manometer out through a window or a door, can be very useful. You can also do this to demonstrate or measure stack effect. Warm air rising, you measure it at the top of the building. We're going out. At the bottom of the building, we're coming in. Sorry, cold climate chauvinism here. That's how it behaves in the winter. But there are other times where you might need to feather it in and get a little bit more resolution. Energy Conservatory offers a piece of software called TechLog, free download. You plug a manometer into your computer and you can real-time graph your pressure relationships. This is great if you're trying to figure out, are we getting pressure differences because of the air handler or because of the exhaust fan or something else? You switch things on and off and you can see whether the pressure dips or rises, and it's all recorded and you can look at it later. You can also put a bunch of manometers together. For those of you who run blower doors, doing the testing with a duct blaster is incredibly useful if you are doing multifamily residential units, small houses, tight houses, passive houses, that kind of thing. If you only need 2,000 CFM instead of 5,000, it's a heck of a lot less stuff to carry up the stairs. So moving on to just a random case study where I'm using some of these tools. So this is a academic pool building, upstate New York, climate zone 6. They actually did a massive renovation, stripped the outside, reclad it, new insulation and everything. And the first winter of operation, they're seeing all of this ugly efflorescence staining at the top of the building. What the heck is going on? So they sent me a bunch of construction photos and they built it pretty much what everyone would recommend for a pool building, the perfect wall where you put all the insulation outside of the structure. So they ripped it down to the original structure, the CMU block, put on a fluid applied air water vapor barrier, rigid insulation on the outside, pintle ties, brick veneer. That's great. That's awesome. That's condensation resistant. Their roof was great. They put on a peel and stick vapor barrier on top of the plank slab and then started building their roof insulation on top of that. That all looks really good. What's going on? So, brought out my blower door, started off with a depressurization test, so sucking cold air from outside inward. Infrared camera showed like we have air leakage coming in at the roof to wall interface, exactly would match up with the damage that we're seeing. The architect on the job said like, no, we got that detail right. There's no way we did that. The air leak is coming from there. So, okay, I turn my door around, pressurize the building, so inflating it like a balloon, that humid pool air is leaking out. We got up on the lull. They busted out a chunk of the parapet for us. You can kind of see that opening, exposing the rigid foam in the backup wall. And when we're pressurizing the building, you can definitely smell the humidity and the chlorine coming out of the pool. Slam dunk, that's what's going on. You go ahead and stick your head further into that hole and dig in. You can see that membrane wraps over the parapet, but unfortunately, it does nothing to close up the top of those CMU cores. That's me sticking my fingers into the top of the CMU wall. So, yep, there's a leak there. Problem solved.
So close.
Yep, they were so close. They got everything right except for that connection. So, when you're sussing out air leaks, you're also, like smoke pencils, those are a classic thing to use, definitely useful. Another tool that I use to show airflow is something called a hot wire anemometer. It's basically from the HVAC guys. You have this little probe that tells you what's the velocity and the temperature of the air that's going past that probe. It's really useful if you're, doing a bunch of photo documentation to demonstrate air leakage for a report or something, and you can say like, yep, we got a big gusher of air coming in at this type of a joint. Also, this has this little extendable probe like an antenna whip, so you can actually do this measurement up towards the ceiling instead of getting up on the ladder. Also, when you're doing air, a lot of the time you're doing HVAC. Measurements can vary from, a fancy flow capture hood, a bolometer, something as basic as an energy conservatory flow box, which is useful for measuring exhaust airflows. And frankly, the toilet paper test is always useful and actionable information. Does the toilet paper stick or not? If it sticks, you probably have some decent flow. Hey, it's better than nothing. Um, so changing gears from air, moving to the topic of heat now. I'm going to start off to talk about infrared cameras. This is not infrared cameras 101, but in general, what you're looking for is a thermal anomaly, the hot spot, the cold spot. And there's a lot of interpretation that you have to do. Is it an air leak? Is it a water leak? Yup, it could be any of those. Is it a heat source? Is it a thermal bridge? Is it solar gain? Yeah, all of these are possible. This is just an example that falsed me out one time is the walking this building, the sun went behind the clouds and I didn't realize like, oh yeah, duh, that's where the sun has been coming through the window, warming up the subfloor. So I'm chasing, errant ductwork through the floor for 5 minutes before I figure that out. But most of the time you cannot see air leaks from the outside that easily, but there definitely are exceptions. Here's an edge case example. Northeast conditions, cold day, overcast, not much sun. I'm walking around, standing on the balcony, and there are these giant stripes of heat on the cold brick at the floor ceiling line, multiple cases at each of these stories. What the heck is going on? So this is we go into the units, pop open a ceiling tile, and we're seeing the inside of a steel beam. This is a section of the building. That's the steel beam that I'm looking at over here at the perimeter. They have infill CMU walls. That's down here. And I don't know how many of you can see that blue behind there, but that is the backside of the rigid foam that's in that cavity. There is absolutely no air barrier, and basically every single one of those are, 3/4 inch gap around the entire perimeter of the building is leaking air like a sieve, and they're wondering why they're having condensation on their chilled water pipes. Surprise. Sometimes you can see water issues on the outside of a building, but it's often a case of can you catch it at the right time? Recently after the rainfall, is the temperature rising or falling? Is the water still evaporating? So this is a mass masonry solid stone building. You can see the windows, water shed off the face of those, and then just drool down onto these window sills or at the corners. Sometimes you can catch it, but a lot of the time you cannot. You can also see often thermal bridging through an infrared camera. So, like, I am your guy for infrared shots of architectural landmarks. So you can, so I don't know if folks know Henri Fennell. He is the rock star of spray foam. He's been a guest on here. So he was actually involved retrofitting the Guggenheim. They actually drilled holes through the plaster on the inside, injected foam, and you can see that most of these walls are pretty well insulated except for these weird little stripes lining up vertically. What's going on there? You look at the plan, you can see the whole spiral marshmallow thing going on with the floor that's sticking out beyond and the skylight up there. That looks like, there's the floor sticking out, there's the skylight, and there's the structural rib. That is the thermal bridge that you can't solve with insulation from the inside, unfortunately. So I don't know how many of you are old timers and remember these gun style infrared cameras, $5,000 back in the 2000s, give you this tiny soda straw view. At this point, they're kind of useless on the scale of things. A lot of folks have those plug into your cell phone camera, fantastic invention, work really well. I ran with one of those for a bunch of my years. Some limitations, and what I use nowadays is just a standalone FLIR camera. Fits in a pocket really easily. It does the job that I need to. You can spend as much as you want on infrared cameras, but frankly, this is good enough for what I do most of the time. Just a couple of warnings with those plug into your camera phones. I've had problems with the software hanging on me, the battery drain on those tiny units, especially if you're doing an exterior walk. That connector does snap off. Ask me how I know. Uh, and there are lots of brands and products out there. I know some people love HIK Micro. I've not played with those, but lots of good options out there. One thing to remember though is that infrared cameras show a surface temperature and they can get screwed up by a shiny surface. So I'm walking this building, walking by the elevator going, holy crap, what's that warm thermal anomaly? I think that we have a massive air leak coming down the elevator shaft. And then I look closer and say like, oh yeah, shiny elevator door. That's me. Those are the overhead lights, and that's my colleague. It's just an infrared mirror. Sometimes that's the kind of stuff that can screw you up. Also, sometimes you can get these weird surprises. So, water heater is warm, and what the heck is that blob? And basically, it is the owner's cat perched on the bedroom on the basement shelf, roughly 83 degrees surface temperature, assuming the cat's emissivity is about 0.9. Finishing off temperatures, temperature humidity meters are always useful to have around. You can spend basically as much as you want. Little pen, induct, from the HVAC industry, these kind of meters, $1,000 research grade stuff. But in general, calculating out the dew point is often very useful if you need to compare inside to outside, room to room. That lets you compare the moisture level between spaces. So now we're getting into combinations here. So I'm going to talk about combining the air side and the heat side when we're looking at building enclosure leakage with a blower door with an infrared camera. Probably a lot of you guys, once again, use this technique. You can use a blower door with an infrared camera, find the air leaks with it. The two options are, one is you could pressurize the building so that air is forced outward through the shell. You would stand on the outside of the building to look for those leaks. Unfortunately, there's a lot of cases where like if the sun's hitting the outside of the building, you're just going to see that. You're not going to see anything else on the outside. So the typical go-to technique for the majority of folks who are doing these is we depressurize the building, sucking outside air inward through the shell. And you can visualize the air leaks on the inside with an infrared camera. You're hoping for at least maybe 20-ish degrees temperature difference inside to outside. More would be even better. And you are looking for the hot spots or the cold spots depending on the time of year. So these are just the classic kind of things that you would see, a bad gasket underneath the door. I refer to these as tongues or plumes of air. That's often the pattern that you see with these types of air leaks. This is just a crappy residential wall where giant air leak over at the electrical outlet, the corner of the window, the sill plate, no big surprises there. Um, Tongue and groove often is a massive amount of air leakage, especially where it goes over an outside wall. Basically, every single one of those tongues and grooves is a perfect spot for air to kind of short circuit over the top of your wall, as well as where the beam goes ahead and sticks out of the building. So one wacky case that I had was an art storage building made out of insulated metal panels. So insulated metal panels, they're basically a prefabricated metal with insulation, rigid foam insulation in between. They have tongue and groove joints and they all snap together. This is actually a really good choice for a high humidity building like an art storage building, but they were having a lot of problems with dripping and condensation. So I'm walking around, running the blower door to depressurize, sucking in hot outside air. And you're definitely seeing, yep, they didn't get the joint between the wall and the roof. That did not work out. But another one that's kind of wacky is that there are some of these wall panel joints that are just terrible. And the thing is, you just walk down, they all look identical, but it's the case reality is good, terrible, 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 good. So that's just a warning if you're ever working with insulated metal panels, there's just another level of quality control you might consider. In addition, you can look for air leakage behind interior finishes. This is a case where you have a vented attic above. Summertime, hot air is up in that attic, and you can see that this interior to interior wall, we're sucking air down through the top of that wall, through the penetrations, into that wall, heating it up. Similar for this cathedral roof ceiling assembly, you can see the skylights over here, and you can just see the amount of hot air that we're sucking down through the ridge vent, and it's coming in wherever it can, various openings. A lot of the time I have this fight with designers where they're saying, like, oh, we're spray foaming this building. We don't have to worry about an air barrier. And the line that I always use is that spray foam is a great air barrier where it is and does absolutely nothing where it isn't. So you can see in the infrared shot, yep, over here where we have just single sticks, no air leakage. Corner with the multiple studs, yep, we got a great big air leak right there. So all of those wood to wood joints, yep, those are potential air leaks that you can have. Another one that bugs the snot out of me is where you install windows and they have either the shim packs or like a clip coming back like this thing. Time after time, that's where the air leaks happen, just because it comes through the shim pack, underneath it, underneath the clip. Those are the classic failures. Folks know how to solve this. Tape the whole thing, kooky the snot out of it, as Joe Stiebrick would say in his highly technical language. Just bury the entire thing with sealant. All of these are perfectly reasonable answers. Whole segment that I have on combining air and hot and cold with HVAC measurements, but we'll have to skip over this for time. The takeaway is that there are all these techniques to do measurements for diagnosing humidity problems in buildings, how well your air conditioner is working. I can give an entire hour-long talk on that topic alone. So moving on to water. as we all know, water is the big thing that kills buildings. It's all about water, rain, groundwater. Yes, air leakage can be part of it. Even less, vapor can be part of it as well. But rain is what kills buildings, as we all know. Um, let's jump through this, a lot of the time when I'm looking at a building, there's a great line that Joe says, "Where does the building touch the sky and touch the ground?" If you're a similar geek to me, you're walking around the city in the beginning of a rainstorm. You see the way that the water kind of deposits on the top of the building. The rain whips it around the corner. You get the splashback down at the bottom of the building, and that water drooling off the windows, depending how the water is shed off of that. So you can see some of the high-tech instruments that I use to look at window sills and the critical water shedding ability of these. Like pour water on the windowsill. Does it drain off or not? And this is where I'm telling the guys, like, get it right, guys. Slope downhill out, not that hard. And you can see that they do get it right sometimes. But also, drip edges are critical. What you want to do is shoot that water that collects off the window and not let it drool onto the wall exactly as you're seeing down here. So smashing your drip edge up against the backup wall, terrible. That's what causes these kind of problems. This is a John Straube image. You want to push your drip edge a minimum of ½ inch away from your backup wall to make sure that's shedding. So getting back to actual instruments, the standard ones that I'm pulling out of my kit, Delmhorst wood moisture content meter, basically a pin-based meter that you can shove into the wood, measures the moisture content by electrical resistance, or one of these capacitance style meters like a Tramex meter. They have these rubber pads. You set it on the material. You can measure wood. You can measure masonry. You can measure drywall. It's a pretty useful jack of all trades kind of meter. So just to give you some context on what those wood moisture content measurements mean, something wood that's below 20%, that's pretty much safe. Don't worry about it. 25 to 30%, you're getting up into the risk range. Mold can start to grow on wood at that point, but there are plenty of cases where, wood gets up to that moisture level and just survives just fine. It's not rotting or anything. 28% plus, we're getting up towards wood fiber saturation. That's where you're getting decay fungi and really bad stuff. Really wet wood is obvious. You can put your hand on it. It feels cool and damp. You slam your moisture meter into it and you can feel and you can hear it kind of squish as you stick it in the pins into it. And also when you're interpreting moisture measurements, don't forget that temperature plays a role. If the wood is only soaking wet in the middle of winter, it's the same as putting your food in the freezer. Mold does not grow very quickly when it's frozen solid. If you have wood that's moist and in the middle of summer, that's when you definitely have mushroom farm territory. So back to that capacitance meter, you can measure wood moisture content, and it shows non-wood materials on a 0 to 100 relative scale. So what does that mean? Is that a good thing? Travis, hey, welcome.
Better late than never. Please continue.
So concrete can get wet. It doesn't really care if it's wet most of the time. So first of all, what's useful often is what are the patterns of wetting? What are the wet spots? Looking at a basement wall. Yep, the part that's deeply buried, that's where the water is seeping through. Big surprise. Also, is a water leak still active? I'm often looking at these old masonry buildings, and the 100 years old, bubbling plaster, and like, is this an active water leak or is this water damage that happened during the Eisenhower, era? I don't know. So that's what you throw the moisture meter on it to see. This is a great case study, but I'll have to skip this. But another way you can use a moisture meter or a temperature and humidity meter is looking at moisture inside of slabs. There's this whole fancy ASTM test, the F2170. You drill a hole and you stick a moisture meter into it, temperature and humidity, let it sit, and you measure how wet it is. So this is actually a forensic case of they built a sleeper and wood floor system over a slab on grade. They did it too fast and all the wood started curling. So they asked me to say what happened and basically measure the slab moisture content. Like, yep, that slab is plenty wet. The moisture evaporated from the slab, got into the wood, it curled, game over. And so, like, I pushed into the bottom edge of the slab, for instance, and that was 95% humidity still after about 4 months or more of drying inside. Concrete can hold onto a lot of moisture. You gotta watch out for that, is the takeaway. Um, so moving on to another combination, water plus air. So we're talking about window testing. I don't know if any of you guys do big commercial buildings, but one of the standard things that are done on these big buildings is, a commercial window test, an AMA 502, ASTM E1105. That involves getting a vacuum chamber, basically this clear tent on the inside of a window, and they suck a negative pressure, and then they have this spray rack that's blowing a calibrated amount of water, certain gallons per square foot per hour kind of thing, and then they depressurize while blowing the water on it. This is typically done by a specialized contractor that does this type of testing. It is a fantastic quality control test. This is frankly a massive amount of water, like we're talking hurricane level. So the takeaway is if it can survive this type of an, E1105 test, it's probably not going to leak in service unless you leave it open. But you don't need to do that fancy of a test. So this is just a diagnostic style window test. Modern new construction out in the Midwest. Yup, the tenants are reporting this kind of, damage down to the base of the windows. He's sending me photos going like, ugh, mulled windows. That is a classic thing that causes problems. Yup, some of the water leak stains are coming in at the mulls. So a lot more of an informal water test is you just fire up the blower door, depressurize the building to simulate wind hitting the outside. And you can either make a little spray rack out of, lawn sprinkler parts or just spray water on the outside of the window, give it a little bit of time. And a lot of the time you'll see that water, coming in right at that mull, the classic failure spot. Another tool on these type of tests, calcium chloride paper strips that are water indicator paper. A lot of the time, if you have a adversarial situation, you have things like, that's not really a leak in your photo, it's just a shiny spot. That's just some oil that's left over from the process. Like, here, the paper turned pink, it's water. Really. And also you can do stuff like stick it into the crack between the extrusions. And you can say like, yep, water is getting to the back here. If it's getting to the back, it's bypassing all of these seals. It's on the dry side of the window and it's causing a leak. Injecting water, finding the leak from there, basically fine tuning where it comes in. You can also use water and heat together, the classic thing of using an infrared camera to find a water leak. This is open cell spray foam in a ceiling, bad wall to roof flashing. Yup, big wet spot. No big surprise. Water is evaporating, cooling off. This was a investigation in coastal California where it is a roof deck with a glass railing. The deck is sloped to drain water downward away, and they're getting all of these failures of the stucco that's below the deck. And what seems to be going on is that water is supposed to drain past the glass railing shoe, but it's not because of an installation defect. So the problem is, you can probably tell by these photos, it was a wet, rainy day in California. What am I going to do? Pouring more water on it is not going to change the temperature. But a trick you can do is go ahead, get some hot water, put it into your water bottle, and just pour it out. And presto, infrared signal on your camera to find that. So over on this part of the deck, yep, the water drains nicely behind that glass shoe, is not causing problems. Over here on this part, the glass shoe is blasted up against the stucco. There's no drainage. It's backing up and then getting into the stucco, causing this type of damage. So can I finish off a few more slides, or do you want to switch to Q&A at this point? Okay, just a couple of things. I'm just going to talk a little bit about investigation photos because a lot of the time we're presenting stuff in a report. Reports have photos, you got to organize stuff and keep track of them. A lot of the time I'm walking off of a day on site with 500 plus photos on my camera. I have to use every single breadcrumb I can to keep track of where did I take this photo, what was going on. So as soon as you get off the elevator, get out of the stairwell, take that picture of what floor am I on? Am I in the basement now? I'm in the hallway, so we're starting our walk counterclockwise. These are the kind of things that will keep you sane when you're looking through your giant pile of photos later. Also, a lot of the time, I'm dealing with new guys who are, just incredibly excited and they're taking photo after photo of the close up of the opening or the moldy spot or something like that. And guys, back up, take the context photo, walk it in. So, somebody is realizing, okay, I am at the wall to the garage. I am underneath the balcony. Just give yourself that context so you know where that photo is being taken so that you can actually interpret it and provide useful information from that. Um, so a lot of the time people ask me, are, borescope cameras, are they useful? My answer is I still have one in my kit, but I've gotten really mixed results from them. So this was an investigation of recent construction, brick veneer, one of these, little bump out copper roofs that's sticking out from the first floor. Owner is complaining about during rainstorms, water is dripping from the little ceiling of the bump out bay. So I want to minimize the damage. I pull out the borescope camera. I'm looking through this 1/4 inch hole and I'm seeing fuzzy stuff. You know, fiberglass, mold, bird's nests. I'm not really sure. I can't quite tell. So, the takeaway is if you have the option to just cut a hole, stick your big enough you can stick your camera into it, fire off a bunch of flash shots, that's often way more useful, way more informative. You don't always have this choice, but a lot of the time, drywall is cheap. You can cut that hole and you might learn a heck of a lot more. So in this case, I was taking, basically sticking my camera up inside this hole, which is the ceiling of this bay. So this is looking straight upwards. This is the sheathing of the house. That's the relieving angle, and that's the edge of the brick veneer that you're seeing up above there. I turn my camera around and that's nasty. That's the curved roof that's above that bay, and it's Mold City. For those of you who have not investigated this kind of thing, this is basically it's a drain brick veneer, and they've been draining it inside the roof for the past couple of years. That's why this is all rusty, and that's why all this mold is growing. They just forgot to put in that through wall flashing above that. Um, Lastly, kind of embarrassing, but I do use a selfie stick when I'm trying to look at stuff that's where I would have to be standing outside, like on staging or get a drone or something like that, outside of a parapet condition, outside of a windowsill. Hey, it's pretty useful and it's really easy to throw into your kit. Will a drone tell you a heck of a lot more? Absolutely, but that's a whole level of logistics to add on top of that. And I think that's most of what I wanted to talk about here. So happy to talk about any questions that folks have on this kind of stuff.
All right, I got one for you, Kohta.
What do you got?
How do you test a building when you don't have good delta T for IR?
Oh, yeah, basically, if you're doing a blower door test, look for for air leaks. Infrared is your friend. You can try to goose things by pre-chilling it in the summer or preheating it uncomfortably warm during the winter. But if you don't have a delta T, you don't have a delta T. I don't have a great answer. Like I often tell my clients, like, yep, you completed it in beautiful weather, which is fantastic to walk around in and terrible for finding air leaks. you know, Smoke does sometimes work, but that's another tool in the toolbox.
Absolutely.
We had
Go ahead.
Go for it.
As I say, there were several questions that sort of came up, a couple that were answers to questions. So for all the people who are watching the recording, you have to show up live to see the chat box. We'll try to say the things that we want to. So Henry said, do your IR scans at night to avoid all solar gain complications when you do IR. So that was just kind of a great add, I think, to what Coda's slide. But then Lou Harriman asked, Coda, tell us your threshold of concern for WME measurements in indoor gypsum board rather than wood.
Oh yeah, there's actually a fantastic, let me just jump back to moisture meters. Where did that go? Yeah, here we go. So, there's a fantastic, so Graham Finch over at RDH, back when he was a young grad student, along with me, over at the University of Waterloo, he actually did an entire frickin' thesis chapter correlating gypsum board moisture content gravimetric with what you get from a moisture meter. Did all of these, experiments, weighing stuff, and what's the threshold for gypsum damage, all of that. And the takeaway is like, yeah, about 20% moisture content is about where you should start to worry, which is about the same for wood. So like, hey, good number to have. But if you wanted to get into the weeds on that, yeah, look up Graham Finch's master's thesis.
All right. So for an architect or designer, what are the best tools to start with? And then what about for a residential builder?
Yeah, for an architect, designer, and a builder, I think I would put at the top of the list a blower door and an infrared camera. You guys are, probably, you guys do more of, like I come up from a diagnostic point of view. The rest of you guys are more practitioners. So I'll defer to you if you think there's something that should be higher on the list or not.
I would absolutely have said the same thing. I have both of those two things and a whole
Awesome.
bunch of other nerdy tools. I have a
Yeah.
diagnostic background, but those two things I think are critical and important.
I
Yeah,
agree.
and
Both of those are in use on our projects right now. And the only thing I would add is that while you poo-pooed the boroscope, I will
Mhm.
say my boroscope is in regular use, I think
Mhm.
twice last week. So
Nice.
I can't argue that the larger hole is better. And occasionally I'll go with the slot cut because the iPhone will slide up to the slot cut, which is way better than the boroscope. But the Milwaukee boroscope with a light is pretty reliable at the higher res that it gets now. So that would be my only add.
Mhm.
They seem to be leapfrogging the quality. I still own a terrible one, but it seems like if you spend a couple $100, you can get a pretty amazing one now. I'm just once bitten, twice shy, right? I've had terrible
Oh, yeah.
boroscopes forever. So
You know what you need, Ben, is a new boroscope.
Yeah.
if you'd like to buy me one, Trav, I'll gladly use it.
You know I'm in the pocket of big boroscope out here.
Yeah, full disclosure, the one that I own is a Fluke nowadays, and that basically somebody did a write-up in JLC, and I said, sure, I'll try this one. And it's way better than this old Milwaukee or whatever this one is from back in the day.
Old Milwaukee makes a cheap 12-pack, but not a great boroscope. That was a beer joke. Sorry.
I got it, Travis. I got it. Good one.
Oh.
All right. What's your well, here's a twofer. What tool do you use the most and which one is your favorite?
Ooh. Yeah, I would say the infrared probably is my favorite just because, like I honestly bring it on vacation just because I sometimes find fun stuff. It's like, man, this is like the PTAC in this hotel room is just terrible. And like take the infrared shot, like, oh yeah, here's the giant plume of cold air that's just blowing in with the giant unsealed gap on it. Like, oh yeah, my sister lives in a condo in New York City with uninsulated slab edges. Ooh, perfect case study shot of what that looks like from the inside. Yeah.
I was gonna say, after I hung out with Allison, I started traveling with an air quality monitor, and now you've got me convinced that I need to bring my IR camera with him. I think my husband's gonna stop going places with me.
His
But
loss.
I want to ask another IR question, personally as an architect. What's the best bad architectural marvel that you've taken an IR photo of?
Oh, let's see. There was a yeah, I don't know if you heard about Harvard's Fog Museum, but that was a classic 50% relative humidity, pressurized building, fancy architecture, and they basically rotted out their building in like 5 years and tore it down in 10 or something like that.
Mm.
Basically, they were leaking air through all the joints, condensing behind the panel cladding. And early on in my infrared days, I got a shot of it and showing exactly what was going on of infrared, air plume of air leakage getting pushed out around the windows and all these penetrations. And it's like, yep, if somebody walked this in the winter with an infrared camera, they would have seen this on day one. But they basically tore it down and built an entirely new museum addition there. It's like, that's a pretty bad failure, man.
Um, at Penn State, there was an overpass that goes across for the one of the major roads, and it was a Raffaele Vignoli project, and it had a skylight in the middle of it, but it was heated, and we used to call it the death sickle because you couldn't walk in the overpass because they would just get icicles down through the hole in the center of it. That was fun.
Man.
Death Sickle is a great name, by the way. That was the band I wanted to form in college, but was too lame to start. I've got one from our friend Armando. Best time to use
Armando.
Yeah, best time to use an infrared for quality control is after framing and after installation to keep the installers honest. Would you agree, Kohta? I still think I want a temperature differential, so I would advocate for that to be part of the equation, but that's just me.
Well, yeah, sure. An infrared camera is not going to show much unless you have a temperature differential, but doing a walk on the building before finishes start to go up, but after the air barrier is in, or even better yet, combining that with a blower door, fantastic tool. That's a amazing quality control thing that I recommend in all of my air barrier critical projects, like swimming pools, for instance. Once the finishes are on, you're tearing apart Venetian plaster to go solve that air leak. That's the problem.
Just add more caulk,
Yeah.
Spray and
Cut the
pray.
fat end of the tube, Travis, for those repairs.
Yeah, the problem, the way that I explain this to people is that, the finish is not necessarily the air barrier, so you don't have access to the layer. The problem of like trying to seal things on the inside is that's kind of like, emergency room patient shows up at the ER, multiple stab wounds, throw him on the operating table, and the surgeons carefully sew up his raincoat. That's what you're doing by the bleeding is still happening.
Oh, that's a great way to explain that. Perfect.
There was a question since we told everybody they need a blower door it was answered in the chat, but I think that it would be useful for you to say too is what do you do when you have a client that doesn't have a lot of funds, had vermiculite insulation removed,
Okay.
suspect that there might still be vermiculite in the walls? Can a positive pressure blower door test be done?
Yeah, my understanding is that's pretty much the go-to technique if you have asbestos risks, because air pushing outward is not going to draw it into the conditioned space. If somebody knows otherwise, that's great information. But, like I said, you're limited, you might or might not be able to see stuff find air leaks as easily. You can do things like a nighttime test or, a cold overcast day. Whether or not you can find that is another question.
But no depressurization.
Yeah, that, also, sucking soot down fireplaces. I think all of us who've done blower doors have done that and head smacked ourselves from that kind of thing.
Been there, done that.
Oh, yeah.
What about the new ultrasonic, excuse me, just sonic, the new sonic leak detection
Yeah.
device? I saw Randy talking about that a little bit. Is that something that you have utilized? Do you like that technology? Is it useful to you, or is it just fancy pants?
Oh, I have seen them. I've seen them demonstrated. That looks like an amazing tool. But so one of the massive advantages is that you do not have to have a continuous envelope in your entire building. I'm dealing with this a lot of the time, giant house where they're doing, you know, still putting in windows on one wing and they're doing drywall and trim on the other wings. So there's no way in good time to just say, okay, stop finishes. We're doing our whole building blower door test. That's a problem. So doing that type of an ultrasonic leak test would be an ideal use case. And they do work. It's pretty slick. That being said, they're pretty darn pricey. So I think it's mostly in the realm of specialized air testing contractors, not just folks who want to play with stuff and find the air leaks here and there.
We got to do a demo with the head of ASIN, who makes like the flow hoods and stuff like that, and they have a ultrasonic one that also then couples the audio reading with a visual component. So basically, it pulls you get the audio leak through, and you scan over it in a grid pattern with a microphone, and then it transposes that like picture overlay with a visual representation of where the leakage is, so that you can kind of, give some sort of feedback to people that aren't standing in the room seeing the test be conducted. But again, I think it's, new car cost. Inexpensive new car, but still new car cost for air barrier testing. And I love a good tool, but yeah.
That's flipping cool though.
Totally.
I think they need to sponsor you with one, Ben, and then I need to borrow it from you.
I'm trying, Travis. I'm trying, buddy. I'm trying. I just want to play with it and then write it up and talk about it.
There you go. What about from our friend Ralph? Mold in attics is very common. How do you approach from a diagnostic standpoint if you think air sealing will help? Pressurized blower door? That's the verbatim question from Ralph. But obviously, you've addressed that a little bit. If you're talking about from a diagnostic standpoint, is air sealing always the answer with mold?
Well, typically mold in attics, vented attic, molded the sheathing kind of thing, that the classic reason is air leakage from the interior, condensing on the sheathing, frosting, etc. There are weird edge cases out there in the West Coast. RDH did a fantastic study where you have really good insulation, really good air tightness, and just night sky radiation chills down your roof sheathing enough that you're getting condensation like dew on grass. And it's like, well, crap. Like, you just can't win. But I think, as far as I know, that's more of a West Coast thing, just given how dry the dew point, how low the dew point is here on the East Coast, for instance. Not sure if that's directly answering the question or not, but that's where I would go. I would air seal an attic like that.
Miguel Walker had a great one.
Yeah.
How do you become really rich doing just diagnostic testing?
Don't have a great answer for that. I have been in a very fortunate position, basically studying under Joe Stiebrick and, following his coattail. So, that's, I can only claim blind luck on that factor, frankly.
To me, that's the dream job. And I think Miguel's hinting at that as well. Yeah. Increasingly, as my career develops and I find myself doing more and more of that, I absolutely love every little bit of it, because you get to push yourself to understand and think rationally and discover things that you never would have guessed about how things are working.
Yeah, one diagnostic thing that I don't know if you folks have seen this, but I've seen this more and more is unvented spray foam roof, nice and airtight, peel and stick over the whole thing, but they're reporting dripping coming from the eave box. And it's one of those classic problems of great air barrier at the wall, great air barrier at the roof. Connection, we'll do it with spray foam. The problem is that's the one last spot where air leakage is happening. It's towards the top of the building. Outward air leakage condenses inside the soffit box and drips come out of it. And I've literally diagnosed that more than half a dozen times at this point.
Wow.
There's a question about stone foundations below grade in the Northeast, not wet, but damp stone. they're looking for suggestions on how to seal and then subsequently to insulate that rather than that don't include digging out the exterior. So if you have a magic bullet to resolve damp stone foundation wall condition from the interior to solve it and insulate, that's what our viewer is asking about.
Yeah, I can only offer up Joe Stiebrick's go-to solution, which is what I've implemented on a bunch of projects where basically you have a leaky rubble stone wall foundation. A river pretty much runs through it. The choices are we dig up the whole flipping thing and waterproof it, or what he did in his house is gravel around the interior perimeter, line it with some type of waterproof membrane. He used ice and water shield patched together. My go-to nowadays is a dimple mat, but you could possibly even use sheet polyethylene, shoot the whole thing with closed cell, and you basically have air control, water control. It basically, yeah, let me just show you a cross section. Everybody's seeing this, correct?
Yes.
Basically, you're capturing the water that comes through your stone foundation, draining it down to a perimeter trench, goes to the French drain, out to a sump, cover the whole thing with closed cell, air barrier, water, thermal, vapor, pretty much all there. Is this expensive? Absolutely. Does this use spray foam? Yes, it does. But, frankly, when I'm dealing with a project where the client says, "Oh, and I want to put my wine cellar down here." Okay, this is what we're doing.
We just had to deploy that. We had a project where we had to do a fair amount of blasting, and there was just one corner that couldn't get blasted enough. So you had this iceberg of bedrock coming up through the foundation slab. So we wrapped it in dimple mat, fastened it with fasteners, polyethylene over that, and then just closed cell the living heck out of the whole thing, and it's working great.
Done. Yeah.
Well,
The air leakage problem with the dimple mat being solved with the spray foam is the only defense of the closed cell I can offer there. We just got through a nightmare blower door on a rehab that we're doing that started at 15 ACH 50, and we got it down to 13, and we were real proud. And I was
Wow.
like, oh, it's because we have this continuous dimple matter on the entire foundation that's
Ooh.
communicating directly with the outdoors. I don't think we
Mhm.
can solve that unless we do X, Y, and Z. And they don't want to spray foam the entire interior, and they don't really want to resolve that opening another way. Would you be okay with just some caulking at the top edge if we brought that dimple mat high enough up and then sealing the upper dimple mat to the lower dimple mat that right now is just 3/4 of an inch above the concrete slab? Would that be acceptable for continuity, or would you still want like grace, ice, and water over that? Or assuming that I'm not going to spray foam it, which you just answered the question. I'm asking for a different answer to your question.
Yeah. Well, usually what I do in these type of retrofits is I run my dimple mat at the below grade portion and maybe 6 inches above grade. So if you have access
Mhm.
to the top edge, whatever works as an air barrier works. Cut it, with, term bar and membrane,
Mhm.
caulk, low expansion foam, whatever makes it stop air leaking will do that job, frankly.
In those retrofits, Coda, how critical do you think it is that we have that capillary break
Oh
between the
yeah.
top of the wall and the structure?
Yeah, so I don't know how many of you folks caught that or you've seen Joe's presentation on this before, but he actually details running that interior membrane up over, to create a capillary break between the wood and the foundation. Literally lifting the house segment by segment with bottle jacks. To me, this is the most robust, but it's also getting into kind of crazy town range. I'm gonna live without that, frankly, most of the time, depending on, like, for instance, how near is this to grade? Can we go ahead and poke some ice picks into it just to make sure we are not burying some damage right here? Because, one time they were doing this kind of a detail and they literally started jacking the thing and the whole joist just kind of ripped apart because it was that rotten. So, when before you cover stuff up, you want to make sure that the problem's not going to get blamed on you.
We call that a change order, Kohta.
Indeed.
Sounds like time for a new LLC, Ben.
New cell phone number.
Reorganize under a different name. That's
All right.
terrible.
Well, I got to ask Kohta a question here, and this is partially selfish. I'm just have sitting next to me a new tool that I bought for myself, which is heat flux sensors.
Oh, wow.
Have you played with those at all? Any experience, tips, insight?
Yeah. I have used heat flux transducers in a research setting. Basically, that's like taking a chunk of wall and is telling you how many BTUs are going through it. It's kind of interesting in a research perspective, but honestly, like a therm model or just hand calculations, most of the time give you the 95% answer on most of the straight up heat flow questions. Stuff gets weird when we're talking about moisture more than that. There's never harm to collecting more data, though, is one takeaway.
We're trying to collect data on something that there's not a great lot of precedent for, which is a panelized straw bale construction. Right, the data points across the planet are like a dozen, and they're wildly from one end of the spectrum to the other. So that's why we're doing it. And I just like having an excuse to buy cool tools and play with them. But
dork.
Yeah, that's fair because straw bale is both a fair amount of insulation plus the thermal mass factor. Yeah, what does that net out to?
Yeah. Awesome. Well, I hate to be the bearer of bad news, but it is 7 o'clock, guys. This was fantastic. One of my favorite. I love diagnostic tools and getting to hear all of the fun ways that people do that. So thank you, Kohta, so much for sharing your valuable time. And for those people who didn't catch on all those lovely articles he was sharing on buildingscience.com, if you want to go down a rabbit hole, you need to know something. Great way to follow up. And again, if you're watching the recording, you missed a great chat box. There was plenty of things we didn't get to. The questions asked and answered in the chat. So show up live.
Thank you, Kohta.
Thanks,
Hey,
Kohta.
great seeing everybody. Thanks for hosting.
Thank you.
Thanks, everyone.
Great
Okay.
to see you. See you next time.
Bye.